These are some basic commands used for creating surfaces and polysurfaces. The general workflow in Rhino in order to create a surface or polysurface is you use a command to turn curves into a surface. So you generally always start off with curves. So one example is the extrude command. So if I draw a rectangle with the top viewport and type in the extrude command, select curves to extrude, and then the extrusion distance. So that is the extrude. So that's what happens when you draw a rectangle in the top viewport and extrude. So what Rhino is doing here is it's extruding the planar curve perpendicular to the plane of that curve. It's extruding in a perpendicular direction. When you extrude, there is an option here which says both sides. So at the moment it's no, but if we click on that, and so what it's doing is that rectangle is planar, it's extruding it perpendicular to that direction. So if we start that extrude command, and before we started it in the top view, if we start that exact same extrude command but in the front viewport, it has no effect on the direction. It's still extruding it perpendicular to the plane. Just do it in the perspective viewport. Still extruding it perpendicular to the plane. So if we draw a square like that on the front viewport, extrude it, again what's happening is it's extruding it perpendicular in a direction that's perpendicular. So if you were to take that curve and copy it, and now let's rotate it. And then we'll do the extrude command. Same thing. It's extruding it in a perpendicular direction to the curve. So that's all extrude really is. Depending on what viewport you have selected can make a difference if it's a one-dimensional curve. So if I have this, that is a one-dimensional curve. So if I extrude in the top viewport, it's extruding it in the z-axis. So now if I do the exact same extrusion but do it in the front viewport, if I extrude all the front viewport selected, it's now extruding it in the same angle of the front viewport, which is the y-axis. If you have a one-dimensional curve, you just got to be careful that you're extruding. You got to be careful what viewport you have selected when you extrude it, and again, the perspective viewport works the same as the top viewport. So one option we've been over is the extrude both sides. If you just want it in one direction, we'll extrude it in one direction. There's another option up here that's really useful, which is solid. Because yes, that means it'll automatically cap the ends and turn it into a closed poly surface. So if we deselect that so that it's no, it will then be hollow. It won't automatically cap it. There is one more important extrude option. So if we do an extrude, let's turn it back to a solid, and that is if that's the direction. So if you want to extrude a planar curve in any other direction that isn't perpendicular to the plane of that curve, that's when you click on this. So it says base point for direction. I'll click here. And second reference. So what it's going to do is it's going to extrude it in this direction. See how the extrusion didn't take place perpendicular. It extruded it off in that direction. So let's do another example of that. If I were to move it like that, rotate it. If I just do the usual extrude command, extrude it perpendicular. But if I click on direction, let's just say I want to extrude it directly up and down, and both sides. You can extrude curves that are non-planar. I don't know why you would want to do that though. I think I've only done that once. So if I select a control point and pull it upwards, this curve is now no longer planar. So if I have the top viewport selected and I start the extrude curve command, select curves to extrude. So what's happening here, generally when you extrude, it'll extrude it perpendicular to the plane of the planar curve, but it's different if your curve you're extruding is non-planar like this. So what happens is Rhino will extrude it similar to that if you're extruding a one-dimensional curve. Because I had the top viewport selected when I was extruding, it's extruding it in the same angle of that view, which is the Z axis. Let's see what were to happen if I were to extrude it from the right viewport. Extrude this non-planar curve. So it's doing the exact same thing. Okay, it didn't work. One input was not extruded because it would have made an invalid surface. So I guess extruding this non-planar curve from the right viewport didn't work. But that's not really important to understand about extruding non-planar curves because you generally wouldn't want to do that. Another command used to create a surface is the planar surface command. So what the planar surface command does is it takes a planar curve and fills it in. So if I type in the planar surface command, select planar curves to build surface, press enter when done, that's what it did. It just filled it in with the planar surface. So you can see what the extrude command and the planar surface command had in common. You start off with a curve and then you use a command to turn that curve into a surface. So something to note with the planar surface command, it will only work if the curve is closed. So if you have an open curve like this and you do the planar surface command on that, it says nothing happens. It says no faces were made, curve must be closed and planar. So that's the reason why it didn't work. And again, it won't work if you have a non-planar curve. So if I take this control point here and move it up, this curve is no longer planar. And if I try the planar surface command, it won't work. No faces were made, curve must be closed and planar. There is another command you can use to fill that surface in, but it's not the planar surface command. The planar surface command can also work with edges of a surface. So if I create a sphere here, then if I trim, so I just trimmed a hole in this sphere, and this edge here, if that were to be a curve, it would be planar. So you can use the planar surface command on that. Then you can select that and select that surface and join it together to create a closed polysurface. Another way of filling in this surface here, instead of planar surface command, is the cap command. So if I type in the word cap, select surface of polysurfaces to cap, press enter when done. That's just done the exact same thing. The cap command can be faster because you don't have to then join the two surfaces together, and it can work if you've got multiple holes that you want to fill in. Let's look at the Revolve command. So with Revolve, what Revolve does is it takes a curve and revolves it around an axis. So if I type in the Revolve command, select curves to revolve, that's the curve I want to revolve, press enter when done. So now it's asking for the axis. So let's just say that the axis is right here. That's the start of the axis, that's the end. Now it's asking for the angle of the revolution. So it's set, the start angle is set to 0. I'm just going to accept that, hit enter. And then the end of the revolution, which means that's what the revolve is. So I want it to be a 360 degree revolve. So it's got 360 here. So I just hit enter. So that's what's happened. It's just taken this curve here and revolved it around that axis. So again, same with the extrude and the planar surface. You start with a curve and then you use some sort of command to turn that curve into a surface. So let's do another revolve. This time let's do a few things different. Let's revolve that curve, but this time we'll make the axes on a bit of an angle like that. And then second of all, we won't revolve it the full way around, just partially. So the revolve command can be used, the most obvious area it can be used for making parts of furniture is anything that a lathe will make, so turned chair legs. Join them together. Let's revolve this, start of the axes. I'm going to type in 0 degrees, and I'm going to type in 360 degrees. So I just revolved that to create a cylindrical chair leg. So that chair leg there could be made by the revolve command, or it could be made by the extrude command. I'll extrude this. So there's multiple ways of making certain shapes. This one here, this will make a coned shape leg. So if I do the revolve command, select curves to revolve, that's the axes. That is the cone shaped chair leg. So some other examples of how the revolve command can be used is a curved banquette. So that right there is 2 meters. Let's just say the inside radius of the banquette was 2 meters. Let's just say that was the side profile of your banquette. Now let's revolve that along that axis there. Select curves to revolve, press enter when done. That's the axes. And I just want to revolve it from there to there. So I just created a banquette in the shape of a semicircle. I can cap this with the cap command. That fills it in so that it's a closed polysurface. And then if I wanted to, I could draw a line coming out like there and mirror this. Then extrude these two curves and then use the split command. Select objects to split, select cutting objects. So that's just split the banquette. And then I can cap. Move it with the move command. So another example of the revolve command used in furniture. Let's have that 2-meter radius again. So a curved timber banquette, like the Bondi. You've got the front rail, got the back rail, and then you've got the top section, the top back rail. So if I revolve, that's the axis of the revolution. I'll go into my top view. It's not to proportion, but that's the front and back rails of a curved banquette. Another example of the Revolve Command could be for a round tabletop that's got a chamfer. So if I draw that side profile with a round coffee table, if I revolve that around this axis here, do that again, 0 to 360 degrees. Just created a round tabletop with a chamfer. So that's pretty much it for the Revolve command. Another command is the pipe command. So what the pipe command will do, I turn on the gumball here, start moving these points around, control points. So if I type in the pipe command, it says select the rail, that's it. So it says start radius, just going to type in 20. Now it's asking me for the end radius, I want it to be the same, so I'll just hit enter, enter again, and it's just turned this into a tube. This curve here, it's just created a 20 mil radius around that into a pipe. So again, you start with a curve and then use some sort of command to turn that curve into a surface. This one is the pipe command. So this pipe command has all the same radius around it. You can do a pipe with different radiuses. Let's start the pipe command again. Select the rail. So the start radius I'll make small, and then this end radius I'll make large, and then hit enter. So it's just gone from that larger radius and blended it all the way down to that small radius. You can create more profiles along that curve. I'll show you how to do that. So if you do the pipe command again, select the rail. Let's go for a small one. Let's go for a large one here again. And now what it's asking you is a point for another radius. So if you want another radius, which I do, I want another radius right there. I'm going to make this one a large one. Now on another point for a radius, right there, and I want to make that a small one. Then I'm going to hit enter. That's just created that shape there. So how you would use pipe to make some furniture parts. An example is just a simple cylindrical chair leg. Pipe that. So again, there's three ways to create a cylindrical chair leg. You can extrude it, pipe it, or revolve it. So the most obvious way to use the pipe is for bent metal. So let's just say you have a chair base like that. Let's just say the chair base looks something like this. You can then use the fillet command. No, let's change the radius of that fillet to 50. Then fillet this here. Then I can use the pipe command. And what I can do is I can mirror it, the mirror command. So that's just created some sort of base for a coffee table, or you could use a similar style to that for a chair. Let's take a look at another command now, which is the sweep one command. So what the sweep one command does is it will take a curve and it will extrude it along a particular path. The extrude command will only extrude a curve in a straight direction, whereas the sweep one command will extrude it not in a straight direction. It will extrude it along a particular path that you define. So if I type in the sweep one command, so it says select rail. The rail is the path that you want the extrusion to take path along. So that's the path of the extrusion, so I'll select that as the rail. Then it asks you select the cross-section curve. So that's the profile that you want to extrude along that path, and that's the profile I want to extrude. Hit enter when done. So that's just extruded all the way along there, around. So let's delete that. This here, this doesn't have to be centered like that. It can be off to the side. Let's extrude this along that path, so that's the sweep one. Select the rail, select the cross section curve, enter, enter. So you can see how it's extruded it. So something that's important to take note of this is this curve here. It's a planar curve and it's in a perpendicular plane to the end of this curve here. They are perpendicular, and because they're perpendicular, this curve here, when it's extruded along this path, it'll remain perpendicular the entire way around. So if I do that sweep curve again, I do the sweep curve again, select the rail, cross section, enter, enter. So let's take a look at what happens. I'll copy that. If it's not in a perpendicular plane, I'm going to rotate it. So I'm now going to sweep this along that path. That's the rail, that's the cross section, enter, enter. So it's kept that same plane in relation to this curve, the same all the way around there. I don't know why you would ever want to extrude something. I don't know why you would ever want to do a sweep one where the cross section, the profile that you want to extrude along a path isn't perpendicular to the plane. So something important with sweeping is to get the rail and the cross section around the right way. So I'm extruding this along that path there, but if I extrude this along that path, you'll get a completely different result. So let's do sweep. Now let's select this as the rail and that as the cross section. It does something like that, which isn't what we want. So yeah, getting the rail and the cross section, getting that correct is important. So how does the sweep one command then relate to furniture? Let's go into the front viewport. I'm going to type in 50 mil. Let's just say this was the back of a chair. I'm going to join that. Let's come up into the top viewport. Let's draw and draw a path. So I'm going to offset this curve 50 mil. Then I'm going to, this profile's around the wrong way. I'm going to rotate it. going to move that from here to here, and then going to rotate it. So I just offset that curve in 50 mil, and that distance of the profile, that there is 50 mil as well. So I now know that this curve here, this planar curve, is in a perpendicular plane to both these here. So I don't need both these curves, I can delete one. And then what I'm going to do is do a sweep one. Select the rail, select the cross section curve. So I've just created a chair back. And come into the top view. So the sweep command can also be used to create a round coffee table with a chamfer. So if I copy this circle downwards, and then if I offset this in there, and then move that down, actually I'll offset it further than that. Through point. So offset it there, then move that down. Then what I want to do is draw a curve from the quadrant. So that curve there, because I snapped all to the quadrants of the circle that are all centered, that curve is perpendicular. So what I can do now is a sweep. That's the rail, that's the cross section. Then I can use the cat command. So you can create this by revolving it, or a sweep one. You can use this for an oval coffee table with a chamfer. The exact same way. Let's copy that downwards. Then let's offset it and move that down, whatever measurement. I'm going to snap to the quadrant, end, and then I'll do a sweep one. This time that'll be the rail, that's the cross section, and then cat. So that's how you create an oval coffee table. When you think about a sweep one, it's very similar to a pipe. So I create a freeform curve, turn the gumball on, and start moving these points around. If I create a circle, then transform, orientate, perpendicular to curve, snap to the center. It's the orient curve, the end. So that is now in a perpendicular plane to the end of that curve. So then what I can do is sweep this profile along that path. So sweep 1. That's the rail, that's the cross section. So you could use a sweep to do something like that, or a pipe. And lastly, let's look at the Loft command. So we go into the top view, create a curve, create another curve, create another curve. Let's move this up. Let's move this one upwards, the move command. So what Loft does is it blends all the curves together. So if I type in the Loft command, select the curves to Loft, enter. So as you can see, this surface has been created by blending all these curves together. So let's loft some closed curves. Move that up. Move that up. So now if we do the loft, that one, that one, that one. So when you're lofting, it's important to select the lofts in order. If you don't select it in order, it won't work. If you select that one, then that one, then that one, then what will happen is it'll blend this curve with that one and then blend that with that, which isn't what you want. You want that to blend with that, to blend with that. So what's showing up here is this. So this is basically the seam for the surface as it gets blended together. And as you can see, they're all reasonably in line. And this arrow is all facing the same way, so it should work out quite well, which it has. So you can run into a problem when those seams aren't aligned. So if I do loft again, so if I move these seams around, if I click on that one and move it over to there, and click on that one and move it over to there, so this will not work out. So if I go ahead with that, that's what's happened. It still lofted it, but because the seam wasn't aligned, that's what's happened. So it's not just about getting the seams aligned, it's also getting the direction of the arrow all aligned. So if we do another loft, that all seems aligned, but if we change an arrow around, it won't work.